Welcome back to Muddy Math, where we take middle school math concepts that are a little muddy and clear them up. Today, on Muddy Math, we're looking at the area and perimeter of composite figures. And all I'm using is Sidewalk chalk. So, doing this alone, I am going to try to trace my outline, my two-dimensional outline of a three-dimensional object, because we are human. We are three-dimensional. If we take a three-dimensional object and boil it into two dimensions, it gives us some information about the size and the characteristics of that object. I'm going to try to draw myself, and then I'm going to calculate the perimeter and area of my shadow. So now that I have the outline of my shadow, I'm going to use what I know about polygons and circles to make sense of maybe my area, the area of my shadow, and the perimeter of my body. So my head looks like sort of a circle, and my core and my rib cage kind of makes a rectangle. I know my hips are circles because they have sort of a rotation, just like my shoulders and my hips, they have rotations. Whereas my knees and elbows kind of only go like a lever, my shoulders and hips move on a ball joint, so that's why I created circle cross sections of spheres. In mathematics, we often use simplifications of more complex ideas to help us just get a better understanding of what's going on. So in that case, let's take a look at my silhouette of my body. Notice when I say shadow, like if you look at my shadow, the angle at which the sun hits my body will either elongate or condense my shadow, but in this case, I'm just using the idea of a shadow to help you realize that this is a two-dimensional representation of a three-dimensional object. A one-dimensional representation of me is my height. So let's take a look at my height. So from crown to toe, my height, a one-dimensional representation of a three-dimensional object, is measuring to be 6 feet. Now I am not 6 feet tall, I'm more like 5'8", 5 feet 8 inches. But remember, this was just me approximating my height on a graph. So we know that the scale's a little off, but that's pretty obvious. So the height of my whole body is, it says 7 feet. Now, is my wingspan the same? My wingspan is turning out to be about the same. So my wingspan and my height of my chalk person is about 6 feet. Now you see that if I were a big circle, okay, what is the two-dimensional area I could take up in this circular region with my legs and arms? Well, the diameter of the circle, my height, is about 6 feet. I'm going to say that my belly button is probably the center. So if my diameter is 7, what is about the area of this large circle? Well, we have to square the area. So 7 times 7 is 49, which is about 50. And then we have to think about those square units, so it's 50 units squared and 50 units squared times pi gets us an area of about 150 units squared. What did I do wrong? What is the diameter related to proportionally? The diameter of the circle is related to the circumference. So the idea is not that the diameter squared times pi is the area, that's the radius. Okay? So before we jump on to actually determining the area of the circle, I want to show you the radius squared. Okay, so the radius squared fits into this big circle about pi times. The diameter times pi is, not about pi times. The radius squared fits into this whole circle. It tiles the circle pi times exactly. The diameter is the circumference. So if I take my height, it's about 6 feet, I should be able to wrap my body around this circle a little bit more than 3 times. So let's try. I guess I'll go this way. So 1, 2, 3, and a little bit. So the circumference is about 7 times 3 and a little. So 7, 14, 21. Let's give it a push. What's a tenth of 7? A tenth of 7 is less than 1. So let's say 22 feet. Okay, so now time for the area. Remember, the area is how many times a square can tile the surface. So the square unit we're using is of size 3.5 times 3.5 because the diameter is 7, the radius is half of that, 3.5. Okay? So 3.5 times 3.5, well, 3 times 3 is 9, 4 times 4 is 16. Halfway between 9 and 16, they're 7 apart, 3.5 apart. So 9 plus 3.5 is 12.5. So is 3.5 squared about 12.5? I'm okay with that. We can actually calculate it out if you're not completely confident. So 3.5 times 3.5, 5, 2, 6, 8, 0, 5, 1, 9, 10. Okay, so I'm going to say that 3.5 squared is about 12. Works for me. So if the area of this square, I'll shade it in. So the area of this square is about 12 square feet. And this square tiles a perfect circle 3.14 times. Again, we're estimating here, so I'm going to say that 12 times about 3 is the area of the space that my body could cover in a circle if I was pinned down at the middle. So 12 times 3 is 36, so I would say that the area is actually 36. Which is way smaller than 150, which is the area of a circle with a radius of 7. So a circle with a radius of 7 is closer to 150 square units, and a circle with a radius of half that much, 3.5, is much smaller, is about 40 square units. Why is that? Why is it such a difference? Is that a proportional difference? Think about the formula for area. Are we just multiplying a variable times a coefficient? Or are we doing something to that variable that's not linear? You're right, we're doing something that's not linear. We're squaring it. So maybe the relationship is not linear when we're thinking about the change in area as a radius changes. What's something that is linear? The change in circumference as the diameter changes. Because to get the circumference, all we have to do is multiply the diameter by a number, a constant. That constant is pi. But for area, first we have to multiply the radius by itself, and that's called squaring. And whenever we square something, it takes us out of that linear relationship. Linear relationships really only have the variable times a constant. If you are multiplying the variable by something, it has to be a constant. It can't be another variable. Okay, so now for composite figures. If I were to approximate the area of my shadow, what I would do is find the area of all the pieces and then add them together, and then I can go around the outside and determine what the perimeter is. So I'd say the radius of my head is about 6 inches. 6 times 6 is 36. 36 times a little bit of 3, going to round up to 40. 40 times 3 is 120. So I'm going to say that my head is 120 square inches. Okay. Let's say 4 times 4 is 16. 16 times 3.14, I'm going to say 15 times 3.14 is 30, 45. So let's say these are about 50. My shoulders are about 50 square inches. This looks like 5. 5 times 5 is 25. 25 times 3 is 75. So let's go with 80. My hip joints are about 80 square units. My feet look like they're the same as my shoulders, so I'm going to go with 50 square units. 50, 50. Okay, these rectangle legs are 6 by 25. 25 6 times is 150. So 150. The area of my legs are bigger than the area of my head. Remember, we're not talking about the actual head because my head has volume, not area. But we're just, simplifying a 3-dimensional object into a 2-dimensional space. My hands look like they're 3. 3 times 3 is 9 times 3 is 27. So let's go with 30. 30. And then last but not least, we have my torso. And actually this looks more like a trapezoid to me. So what I need is the area of the top, the length of the top base, which is 14, and the length of the bottom base, which is 18, I need to add those two together. So 14 and 18 is 32, and then I need to take half of that. So 32 cut in half is 16. Now 16 times the height of my trapezoid, 16 times 28. So instead of 16 times 28, I'm going to do 15 times 30, and 30 times 10 is 300. 30 times 5 is 150. 300 plus 150 is 450. So I have 450 square inches there. Okay, to get the entire composite area of my silhouette here, I need to add up all these spaces. So I have 50 plus 50 is 100. 150 plus 150 is 300 more, so 400. 80 and 80 is 160, so 560. So I have 560 below the hips. And then my hands are 30 plus 30 is 60, plus 120 is 180, plus 50 plus 50 is 100 more is 280. So I have 560 plus 280 without my torso. 560 plus 280 takes me to 640, 740, 840. And then 840 plus 450, let's round that up to 850, takes us to 9 plus 4 is 1,300 square inches. So I'm estimating that my body is about 1,300 inches squared in area if I were just taking a slice of my body, because I'm three-dimensional, not two-dimensional. Okay, now perimeter. So I would need circumference for my circles here, and so the diameter is about 10, so 10 times pi is about 30. I'm going to choose a different color. Okay, then I have about 25 inches. Now I'm just going around. Okay, in this case, I don't need the whole circumference here because most of it is interior to my body. So I'm just going to measure this distance. I'm going to say that from here to here is 7. I'm going to give it 2 more inches, about 10 we'll say. 10, 2, 10. We're estimating this is probably 25 again. Okay, I'm going to use the circumference of my foot, which is, because my feet have a lot of like intricacies, all the toes, so I'm not going to subtract away this part of the foot circle. So I get 30, 25, 10. Now my waist, from my hip to my armpit, looks like about 20. My arm length is about 20. Again, I'm going to use the whole circumference of my hand circle because of all the intricacies of my hand. And I'm going to round up. So the diameter here should be 6. So 6 times pi, 6, 12, 18, let's say 20. Again, 20. It's funny that this length is about 20 and the circumference of that circle is about 20. It gives you kind of a cool way of looking at one-dimensionality as the circumference of a circle and a line. We'll say that this... Thanks for tuning in to Muddy Math. I hope you enjoyed this interesting perspective on finding the area and perimeter of composite figures. I really encourage you to grab Sidewalk chalk or just break any three-dimensional object into 2 dimensions and then 1 dimension. You know, really taking something that has form and volume and seeing how can I analyze that 2-dimensionally and 1-dimensionally. So 2-dimensionally being like a surface to find area and 1-dimensionally to find perimeter. That's really what you're trying to understand here, is trying to take your mind through the dimensions and say, how can I find composite area and how can I find composite perimeter in objects that are not perfect polygons and perfect circles. Be brave, show up, make it fun, come back to it day after day, week after week, and I know you'll be happy to look back and say, wow, math is fun. Math is really cool. Math should be a part of my life, right? Okay. Well, have a great rest of your day. I'm so glad that you tuned in and that you made math a part of your day today. And I hope to see you tomorrow or the next day or the next week. Check out Mighty Math for more tutorials and activities that you can do to lessen the stress around math and bring more math practice to your life. Signing off. See you next time.